Good evening, NATA aspirants. We are back with our fast track revision series for the NATA August attempt, and today's topic for the discussion is expected questions in physics. Expected physics questions for August attempt. In yesterday's session, we had a discussion about the physics questions that were there in last So, in our last session, we had a discussion. In our last session, we had a discussion on the questions that were asked in NATA paper 1 first attempt and second attempt in the year 2022, right? So today we are going to discuss the possible questions from the various topics, right? So we are going to see it as chapter wise from class 9th and class 10th study material. Vidhi, I hope now everything is visible, and if you are able to see it clearly, please share with a thumbs up and please like the stream so that many more like you can watch this video. So let us start with chapter wise. As per NCERT chapters, we are going to discuss the possible questions that could be there in NATA third attempt. So let us start with the very first chapter from class 9, that is chapter 8 in NCERT sequence, and this chapter is motion, and the headings that are there in motion along straight line. So this is motion in one dimension, basic conceptual questions that could be displacement and distance in one dimension. So if people can, if a person starts from point A, goes to point B, comes back to point C, which is say somewhere in between A and C, and let A and B be 100 meters apart, and this distance between B and C is 30 meters, then total distance traveled by a person, total distance traveled would be 100 plus 30 when the person travels from A to B and B to C, right? And the net displacement would be 70 meters, right? So motion along straight line will have questions like net total distance traveled or net displacement. So these are the basic terms or basic questions that are possible. Motion along a straight line, then uniform motion and non-uniform motion. So if an object is moving at a constant speed with time, then the motion is said to be uniform motion, and if the object is traveling or covering different distances in same interval of time, then it is said to be non-uniform motion, right? So these are the basic concept of uniform and non-uniform motion, and the question can be based on the graphs that you will be given certain graphs, and you need to determine which of the following is correct representation of uniform motion for displacement time graph, for velocity time graph, right? So these are the things that could be there in uniform and non-uniform motion. Measuring rate of motion. So rate of motion is measured in speed and velocity. If we are considering only the magnitude of the object in motion, then we will consider that rate of motion in terms of speed, and if we are considering along with this rate of motion the direction of motion, then we call that term as velocity. So possible definition could be velocity, possible definition could be speed, or the displacement time graph for speed, displacement time graph for velocity, net speed and net velocity. Net velocity can be 0 if the person comes back to the same point, and net speed will not be 0 because we are not considering direction for speed. Alright, let's see the next question, next possible, next title or next heading in the chapter was graphical representation of motion. So here I have already told you the possible diagrams are graphs based on displacement time or graphs based on speed time or velocity time. So these are the three possible graphs. So if you have gone through NCERT book, you can easily see all the possible graphs that I am discussing or I am talking about. So in case of uniform motion, the displacement time graph will show a straight line parallel to time, right? No, that is not the case. If a line parallel to time on displacement time graph exists, then that shows object is at rest. So increasing, so let me draw it here. If this is the displacement and this is the time axis, and the line shows, so this shows the object is at rest. If this is the situation on displacement time graph, a straight line, this shows uniform motion. And if not a linear line but a curved line, so that will show non-uniform motion. I am talking about displacement time graph here. This S represents displacement, T represents time. So on displacement time graph, you will have these three possible conditions for rest, uniform motion and non-uniform motion. The direction of the line could be opposite as well, that is uniform retardation also exists. So if object was in motion and if it is coming to rest, in that case this line could be somewhat like this. So this also shows uniform motion but in negative direction. So earlier object was in moving with certain speed, then its speed is reduced with time, right? So this is uniform retardation or negative uniform motion, and similarly this can be non-uniform, negative non-uniform motion. Okay. Then equations of motion. So there could be questions based on equations of motion. The basic three equations of motion you must be familiar with and you must be able to apply formulas. The three equations are S is equals to ut plus 1 by 2 at square. Before this was V is equals to u plus at. And the third one is V square is equals to U square plus 2AS. Here V is final velocity, U is initial velocity, A is rate of change of velocity called acceleration, rate of change of velocity with respect to time also called acceleration, and T represents time. T represents time, S represents displacement. Okay, so these are the 5 terms that are there in these 3 equations of motion. You could be asked a very simple numerical, as we have seen in case of NATA second attempt, there were 2 numeric answer type questions that there were no options available. but based on these formula you can calculate the unknown parameter and answer it, right? So velocity is having units meter per second, acceleration is having units meter per second square, displacement is having units of meters, right? Instead of meters this could be kilometer and megameter, etc. Centimeters could also be there. Then last heading in this chapter is uniform circular motion. So if an object is moving on a circular track with constant speed, then object is said to be in uniform circular motion, right? And uniform circular motion, here the uniform circular velocity is represented by omega, and that is nothing but v is equals to r omega. So r is equals to v by or omega is equals to v upon r, right? So that v is linear velocity, r is the radius of the circle, and omega is the angular velocity. So these are the topics, and these are the possible questions that could be there from class 9 chapter 8 as per NCERT. These chapters are as per NCERT books, NCERT book, right? Next chapter number 9, class 9 से ही chapter number 9, force and laws of motion. So balanced and unbalanced forces. So balanced forces does not put any object in motion. Unbalanced forces are responsible for an object that was earlier in its state of rest, that is at stationary state, can be brought into motion, or an object that was moving in and that could be brought to rest by applying unbalanced force, right? So unbalanced forces are this one. So next are laws of motion, that is first, second and third law of motion other than these, inertia and mass. So first law is also called law of inertia, that is if an object is in motion it will remain in motion, if an object is at rest it will remain at rest until an external force is applied on it, right? So that is called law of inertia as well. Then the second law of motion defines force. Force is equals to mass into acceleration. When an object is at rest and it is brought into motion by application of certain with a certain rate of acceleration, then that defines the force, right? And that force is mass into acceleration. There could be some basic numericals based on this formula, force is equals to mass into acceleration. Further, acceleration is final velocity minus initial velocity divided by time. So that is v is equals to u plus at, right? From this equation we have derived the value of a. So these equations of motion that we have learned in previous chapter will be used here in these laws of motion. Then third law of motion is about every action has equal and opposite reaction force. There could be some basic numericals, you can refer to NCERT examples as well. When if a person jumps out of a boat, he moves in forward direction and the boat moves, person moves in forward direction with the same impact, the boat goes in reverse direction. If a bullet is fired from a gun, there will be a recoil of the gun. So there could be questions based on these concepts that come under Newton's third law of motion. Conservation of momentum, right? So conservation of momentum principle says net momentum of a system remains constant. So for momentum is defined as mass into velocity represented with p. So momentum before application of force and momentum after application of the force remains the same. If an object was in motion and brought to rest, the force is applied in the opposite direction, or the momentum is in the opposite direction, right? So there could be question on conservation of momentum as well. So please go through the concept of conservation of momentum, that is momentum before coming to motion and momentum after coming to motion of an object, or momentum after before coming to rest and momentum after coming to rest. So with the help of these laws of conservation of momentum, we can calculate the final velocity or the initial velocity or the mass of the objects as well. So these are the basic applications, and numericals could be based on these applications. Let's see the next chapter, that is gravitation. It has got universal law of gravitation, that is capital F is equals to GMM upon R square, where capital G is universal law of gravitation constant, M is mass of earth, small m is mass of object, capital R is radius of earth. So that is F is equals to GMM upon R square. Then free fall, when an object is released from certain height, then it has a concept of small g as well. Mass and weight. Weight is nothing but mass into gravity, that is weight. Mass is absolute of physical quantity that measures mass of any object. Thrust and pressure is important. Thrust or pressure is defined as force applied per unit area, and Archimedes principle is based on this thrust. Upward thrust, when it comes to water, upward thrust is applied by water when an object goes down with certain velocity in water. Water applies certain upward thrust, and that upward thrust is equal to the net displacement, amount of the water displaced by the object, right? Similar question we had discussed in yesterday's session as well, that the question was, when you float on your back in water, what will be the net weight of your body, right? So the net weight of your body was 0, because the amount of water displaced by your body was equal to the weight of your body, hence your weight is 0. So that is Archimedes, that is based on Archimedes principle only. Relative density is a smaller concept. Density is mass upon volume, right? So relative density is calculated as density of material upon density of water in general terms. Density of water is considered to be 1 meter cube, 1 kg per meter cube, that is considered as the density of water, right? Or 1 kg per centimeter cube, or 1000 kg per meter cube, right? That is the absolute density of water, and then relative density is calculated in terms of density of water. So you might be required to calculate absolute density of a given material whose relative density is known to you. Okay, so these are the questions that could be there. Other than these, there are 3 laws of gravitation that are given in the book. So please go through those laws once, because there could be a direct question based on those laws, and as per previous 2 papers, we can say there is a higher probability of getting a question from gravitation part, because it was not there. Other chapters had their weightage, but gravitation was not asked. So a possibility of 1 question is there from the gravitation chapter. Next is work and energy. Work is capacity to do work. Energy is the amount, capacity to do work. Work is defined as force into displacement in terms of physics. We have seen a numerical on it. Work is force into displacement, right? When an object is brought into motion or displaced from one place to the other, then after application of force, then it is said to be some work is done on the object, right? So work done are of two types, positive and negative. If work is done on the object, then work done is said to be positive. If work is done by the object, then work done is said to be negative. Okay, then energy is capacity to do work. There are two major categories in which this energy is defined. Potential energy, when an object is at rest condition, or in a when the speed of the object is zero, it has got potential energy, and when object is in motion, it has got kinetic energy. The sum of total energy of any object is always sum of potential energy plus kinetic energy at any point of time, right? So law of conservation of energy says the total energy of the system remains constant, that is when object is in motion or in rest. This if it is in between, then two. Let us understand with an image. Let's say a stone is placed at certain height h. So it initially, when this stone was here at the platform, so it has potential energy only, and if it is released and it is in between, it has not reached ground, but it is in motion, so it has got potential energy plus kinetic energy both. At the time when the this stone hits the ground, it has got zero potential energy, it has got only kinetic energy, right? So total energy of the system in all these three cases, numeric value of the all three will be same. That says law of conservation of energy. In fact, there are some basic numericals available, solved questions available in NCERT class 9 chapter 11. You can go through them to understand how do we apply this concept of law of conservation of energy. And then the last concept is power. Power is rate of doing work, right? So energy is power into time. Energy is power into time. Energy is capacity to do work. So energy is power into time. Next, last chapter from class 9th, that is sound. So production of sound is not that important, but propagation of sound is important. There could be direct question, the sound waves are longitudinal or latitudinal, transverse in nature, what kind of nature is of sound waves. So these sound waves are longitudinal, so they travel away. As we move away from the source, the intensity of sound waves reduces. So at the source the intensity is highest and they travel in all the directions in general, but if you apply certain restrictions, then the wave will travel with the path that is having lower resistance, and the speed of sound is highest in metals, lower than in liquids, further lower in air, and lowest in vacuum, right? So basically the sound waves use the concept of pressure, right? So they need material to propagate, and if there is vacuum, then the sound waves cannot travel through vacuum. So propagation of sound is important. Characteristic of sound waves, these are the three characteristics. The definitions of these three could be asked directly, right? So please go through the definition of frequency of sound, amplitude of sound, speed of sound. Further, reflection of sound has got certain application in sonar, radar, etc. So you can see that these sonar, radar, and how these reflection of sound, echo of that echo is also defined by the reflection of sound. So when if sound wave travels and strikes to a surface and comes back to the same medium, that is called echo. And in fact this echo is the reason why we hear our voice in hilly areas, right? So that could be there. So same echo exists for sonar and radar as well. Bats and whales use these sonar waves to detect person or object in their path of motion. Radar is the technology that is used to detect motion of planes or objects in air by humans. Uh, right? Range of hearing is also important. 20 hertz to 20 kilohertz is the range of hearing for humans. But other than these, the spectrum of waves is also important, and IR, infrared, then ultraviolet rays, all these are there. Ultrasonic, supersonic waves. So you must go through these ranges as well, so that you can directly answer the questions that are based on such numeric values. Then let's move to class 10th part. So class 10th has got 4 chapters of physics, and the very first chapter is light reflection and refraction. So reflection of light through a mirror. So whenever plane mirror, if there is a plane mirror, if light strikes on it, it will follow certain laws of reflection. That is, the light goes back in the same direction. If it strikes at an angle, so the same angle it will form with the normal and go back in the same medium. So that is called reflection. So reflection through plane mirror is not that important, but reflection through spherical mirrors is important. Here you can directly see the possible 6 possible cases in case of concave mirrors for image formation. Image formation using concave mirrors. There are 6 possible cases, and for convex mirror there are only 2 standard cases. So please go through those cases and identify when the image is diminished, when the image is larger than object. There could be a direct question based on the position of object, based on position of image, and some basic numericals based on the same. Magnification formula, what is magnification formula, what is mirror formula, what is then lens formula. If we talk about refraction, there is a lens formula. Same spherical lens through image formation is there. So please go through all these. Then power of lens, that is defined as 1 upon f, that is focal length in focal length of lens in meters, of lens in meters, right? So when is it positive, when is it negative, what is the unit of power of lens? The unit of power of lens is diopter. And for concave lens it is negative, for convex lens it is positive. So please go through these basic concepts. Then human eye, different parts of human eye can be asked directly. Retina, what is the role of retina? You can be there could be 4 options, and you need to identify the one that is correct or that is incorrect, right? So retina could be there, iris could be there, pupil could be there, eye lens could be there, right? So different parts of human eye. Then defects of vision, majorly 3: myopia, hypermetropia, presbyopia, right? Then these are the 3 defects. How can these defects be removed? Which lens should be used for removal of which defect, right? Then refraction through glass prism, how glass prism refracts the light, and then dispersion of white light into the 7 basic constituent colors, that is of rainbow, that is Vibgyor. And then atmospheric refraction, how does rainbow form, which color bends the most, which color bends the least. So most bent is violet and least bent is red. So you must remember the order. This bends most in rainbow, bends most, and this bends least when a rainbow is formed, right? How does a rainbow form? So when sunlight gets scattered after a rainfall in water droplets are there in the atmosphere, and if sunlight disperses through those water droplets, then the rainbow formation takes place. So these are the questions. In fact, twinkling of stars is due to scattering of light or different atmospheric refraction layers. As we move away from the earth, the density of the atmospheric pressure reduces, so that causes further refraction in the movement of light. So these are the questions: why the color of sky is blue, why the color of sky is black at night. So these are the basic questions. That could be there. So please go through these questions, these concepts to mark the correct answers. Electric current, definition of electric potential. Ohm's law is quite important. V is proportional to I, or V is equals to IR, where V is potential, I is current, R is resistance. Then resistance material, so R is proportional to rho L by A, right? So that is a specific resistivity, length of wire, and area of cross section of the wire. Then resistance of object, there are two resistance in series. The equivalent is R1 plus R2. But it is when there are two resistances in parallel, R equivalent will be 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. If there are more than two, go on, keep adding, right? So there could be some basic numericals on resistance in series, resistance in parallel. Heating effect is P is equals to I square RT. In fact, this is used to determine the electricity bill. So there is a question available in NCERT class 10 chapter 12, how to determine the electricity bill. So please go through that question. There could be a question and you need to answer it in the numerical answer type question. Electric power is again the capacity with which we drive motors and we drive electric appliances. So that power is IV square into our definition of electric power. P is equals to V into I, or this could be V square upon R, or this could be I square R. Using this formula, V is equals to IR, right? So power is defined by capital P, electric power, and it is V into I, potential into current. The last chapter, magnetic effect of current, possibilities are there that electric motor principle could be asked. Electric generator is based on left hand thumb rule, right hand thumb rule. So go through these left hand and right hand thumb rules. What are magnetic field lines? Why are the magnetic field lines closed in nature? Why these magnetic lines do not intersect each other? So these are the basic questions that could be there in your exam. So these are the highlights that you need to go through, and other than these, you can, if you are capable and if your preparation time allows, please go through the 11-12 basic concepts as well. So in upcoming days you will be seeing the various aptitude questions as well. So thank you guys, thank you for tuning in today. Do come back to same channel on Monday, and if you need to go through study material, you can always check our description box and click on the link given in the description box to get the study material for NATA preparation. Thank you. Have a good day.